Okay, relations and functions. Let's dive right into it. So we're going to identify the domain and range of relations and functions, and then determine whether a relation is a function. So we're specifically talking about relations and functions. So here it tells us a relation is a pairing of input values with output values. It can be shown as a set of ordered pairs where x is an input and y is an output. The input values are called the domain and the output values are called the range. So you have, here we have a mapping diagram right here. And in this mapping diagram, the domain is on the left side, the range is on the right side. And we have arrows that will go from the domain to the range to show which ones go together. So if we took these and wrote them as ordered pairs, we could see that we had, since 2 is mapped to A, we have an ordered pair, 2A. Since 2 is also mapped to B, we'd have another ordered pair, 2B, and then 2C, which is not 2B. Okay. Wow. If he got it and the rest of us didn't? Okay. All right. All right. Caitlin got it. She was just quietly trying to avoid the fact that she got it because it was so bad. Okay. All right. So we have the points x, y, which would be input and output, which is also domain and range. So you can think of them as ordered pairs in any of those senses. That it's the coordinates, it's the input-output values, it's the domain and range values. All right. So these are things that we've done many of before. So let's look at them. All right, so here's our first example. They want us to give the domain and range for this relation. Now, one of the things is when we're given the domain, we are doing it in roster notation. So that means that we have to use braces to do it, to write it down. So when I list the domain here, I will use roster notation. Remember, we use braces for that. And then we list each individual number. So 100, 120, 140, 160, and 180. And then we close it with a brace. And then the range is the y values. And since we're once again listing them in roster notation, and we always list them from smallest to largest, regardless of what order they come in. Right? Now, here in the range, we have 5 twice. Do I have to list it twice? No, we don't have to list it twice. We only list it once. We have 2 5s, 2 6s, and a 12. And that would be our range. Don't list them twice. Because if we did a map like they have up here, so if we did maps, they're almost the same size. Go that way. So if I did a map here, then we would list 100, 120, 140, 160, and 180. Okay? We would list the domain in the left side, and we would only list 5, 6, and 12 over here. We would just say that these two both map to the 5, these two both map to the 6, and that one maps to the 12. So we still only list them one time, just like we did here in this map. Okay? Yes, Ruth? Would it be confusing? Well, that's why we use ordered pairs most of the time. We don't use this mapping all that very often, okay? But yeah, sometimes that would be. So you're saying that if we had the point 180 and 5, that if I ran a line here, that could be confusing, okay? All right. Sometimes it's just when the lines are done on there, they're much better than the ones I do. So usually it's not so bad. Right. But if we did a map like that, then yes, you would need to do that. Okay, you wouldn't list them more than once. Okay. All right. So list the domain and range for, check it out, number 1. Okay. All right, so just a reminder, the x values are the domain, y values are the range, and when you list them as roster notation, then you always list them from smallest to largest. A relation in which the first coordinate is never repeated is called a function. In a function, there's only one output for each input. So each element of the domain is mapped to exactly one element in the range. So the one on the left here is not a function. The one on the right here is a function. Okay? The numbers in the domain can only be mapped to one value in the range, okay, for it to be a function. In other words, another way of saying this is for every value of x, there can only be one value for y. So for every value of x, for every value of x, there can be only one value for y. Now, they can all be, like in this one on the right, they can all be the same number for y, but they can't be the same number for x. Okay? And then we're going to talk about how you can, another way you can test this is if you graph them, okay, and they're on top, any of them are on top of each other, okay, above each other, then it's not a function. We'll look at that more closely. Okay? For every value of x, there can be only one value for y. For every input value, there can only be one output value. Oops. Oh, there they are. Here's my examples. Okay. Big gap there. All right, so we want to determine whether each of these relations is a function. All right. So letter A, from the items in the store to their prices on a certain date. Okay, is this a function? In other words, for every input value, would there only be one output value? And it's probably easier to disprove than prove, okay? So think about the items in the store. Okay, you go to Buddy's, all right, and you're looking for candy bars. Okay, you're trying to make up your mind which candy bar you want to buy. So, Nathan, what's your 2 favorite candy bars? Twix and Milky Way. Okay, good options. Okay, I prefer Milky Way dark versus a regular Milky Way, but that's just me. Okay, now, Nathan, there's 2 different items there in the store, right? Okay, and how do the prices compare? You don't know? You think they'd be the same price? Okay. Would that affect whether it's a function or not? Well, you have 2 different inputs, right? And they have the same output, right? Is that okay? Yes, it is. All right. But your favorite one is You have Twix over Milky Way if you had the choice? Okay, all right, so we'll say Twix for this case. All right. Have you ever gone in the store and seen the Twix bar for two different prices? If you did, do you think you would see the same Twix bar for two different prices? No. Okay, so what do you think? Items in a store to their prices on a certain date, would that be a function? Yes. Oops. And the reason is because any item in a store is going to have its own price. It's not going to have more than one price. Okay? So I'm thinking about, does any specific thing going to have more than one value on a certain date then? Yes, Nolan.
Well, what if it changes?
Like, says on a certain date.
Like what if there's a sale on that day? And
Well, then
the day, it was $2.19 and then it was like $1.39.
Now you're getting too technical.
Well, what I'm just
Okay.
saying.
No, that's not usually going to happen, okay? All right? From types of fruits to their colors, okay? So now, we're talking about types of fruit. So the input here is fruits, and the output is their colors. All right? Natalie, what's your favorite fruit? An apple. That's a great choice right there. Okay, an apple. All right? Now, does apple come in more than one color?
Yeah.
Yes, they do. So is that a function? No, this is not a function. Because apples could be red, or they could be yellow, or they could be green. All right, so at least there's those three right there, colors. So an apple could not, or types of fruits of their colors would not be a function then. Okay, so you have to think about a specific item or a specific thing. Could there be more than one of those things? If that's true, then it's not a function. All right.